Today we are going to look at the Leetcode problem, simplify path. Let's read the problem statement. You're given an absolute path for a Unix style file system which always begins with a slash. Your task is to transform this absolute path into its simplified canonical path. The rules of a Unix style file system are as follows. If there's a single period, it represents the current directory. If you see a double period, it represents the previous or parent directory. And multiple consecutive slashes such as double slash and triple slash are treated as a single slash. Any sequence or period that does not match the rules above should be treated as a valid directory or file name. For example, triple dots or four dots or valid directory or file names. The simplified canonical path should follow these rules. The path must start with a single slash. The directories within the path must be separated by exactly one slash. The path must not end with a slash unless it is the root directory. The path must not have any single or double periods used to denote current or parent directories. And then we return the simplified canonical path. So here are some examples. Here the output should be like this because well, here it says directories within the path must be separated exactly by one slash. So yeah, here in example 2 we can see that two slashes there, so we are replacing it with only one slash. We are removing one. And the path must not end with a slash unless it is a root directory. Okay, so here that's why we are taking the slash out. The trailing slash should be removed. And in example 3 you can see that we are removing these two dots because it says that path must not have any single or double dots used to denote current or parent directories. What happens to the triple dots? Yeah, any sequence of period that does not match the rules above should be treated as a valid directory or file name. For example, triple dots or four dots are valid directory or file names. Okay. But a single dot represents the current directory and a double period, a single period represents the current directory and a double period represents the previous parent directory. So here we have this double period here, so it means like it represents the previous parent directory. And also we need to make sure that the slash here should be removed. There should be only one slash between documents and pictures. Okay, so because the double period refers to the directory upper level, the parent directory, so we are removing the documents directory here, and that's why we have to say home slash user slash pictures. And here you can see that so output is just this one. Go one level up from the root directory is not possible. Yeah. And here the output is okay. This is the triple period is a valid file name or a directory, file name or a directory. So directory here in this case, and we are removing A because it's here it's going up one level and it becomes B, and here we are removing C because D is going up one level. So yeah, it's like because we are going from here to here in this direction, we shouldn't confuse it with going from here to here. So what happens if we go from here to here? It shouldn't end with a slash, so we are removing it, and we need to remove the single period because what does it mean? Single period represents the current directory, so it just means the current directory. And yeah, it shouldn't end with a trailing slash, so we need to remove that. And D is going up one level, so we need to remove C. And B is going up one level because of the two periods here. So we are removing A, so it works well even when we go in that direction. And here are the constraints we have. So I'm going to start coding this. So before starting to code, I would like to talk about possible approaches that could be used for this to solving this problem. First approach is that we can split and process with ArrayList. So we can split the path by the slash and get the components. We can use an ArrayList to simulate a stack of directories and process each component. We can skip empty strings or invalid components, and and we can skip single period too. And and then like for removing double period, if you see a double period, we need to remove the lost directory, so we can process each component with these rules. And then for valid names, we can add to the list. So and then build a final path by joining the list with a slash again. We can do that. And but then the time complexity for splitting the string is O of n, which is n is the length of the path. And for processing the components, it would be O of m, where m is the number of components proportional to n. And building the result O of n for concatenating the strings, so total would be O of n. And space complexity is because we are using ArrayList here, which stores at most O of m components, where m is the number of valid directories. O of n in the worst case, splitting the array O of n, output string O of n, so it would be O of n. But the disadvantage here is that ArrayList operations, it adds and remove, the adding and removing operations of ArrayList, they are O of 1 amortized. So by resizing it could introduce minor overhead. And the second approach is that we could use a stack. It's similar to approach 1, but we use a stack or DQ as a stack for explicit stack semantics. And we still split the path, we push and pop the directories based on the components, and build the result by popping elements and reversing by using a DQ to avoid, or we can use DQ to avoid the reversal. So the algorithm is something like we split the path first by the slash, and then initialize a stack or a DQ, and for each component we skipped empty or single periods. And if the stack is empty, and for double periods we pop the directory, and for valid names we push the components. And if the stack is empty, we return a single slash, the root directory. But the path, we can build the path by popping elements, and constructing the string in the reverse order. Similar to approach 1, the time complexity is going to be O of n for splitting, processing, and building the results, and space complexity is going to be O of n. Similar to approach 1 for the stack, split array, and output. The drawback here is popping and reversing to build the result adds complexity. Using deque can mitigate this, but is similar to ArrayList. The third approach would be to pass with character array. So here the idea is to avoid splitting by processing the string character by character. In the first pass, we pass the components and build a stack. In the second pass, we construct the result string, and we can handle slashes and periods manually. And so the algorithm is to iterate through the string, tracking component boundaries, use a stack to store valid components for each component, process to process each component, and then we build the result from the stack. And also, while we store the valid components to the stack, we can, like, yeah. So here the time complexity is going to be O of n for passing and O of n for stack operations, and the result construction would be O of n. So it's to O of n. The time complexity is O of n, and space complexity is O of n again for stack and output, and no splitting the array, but temporary buffers may use O of n. And so space complexity is O of n too. The drawback here is more complex to implement due to manual parsing and error prone for edge cases. So we are going to choose the optimal approach, which is the approach 1, which is split and process with ArrayList. That is the best choice here because it's leverages Java string splitting, which is optimized, and ArrayList, it provides a flexible stack-like behavior without manual reversal, unlike a traditional stack, and it's easier to read and maintain compared to manual parsing, which is used in approach 3. And the time and space complexities are identical to approach 2, but ArrayList is simpler than managing a stack or deque. So now I'm going to start the code. So first I need to split the component, split the path by the slash, and that's going to be and then we are going to use the array list as a stack for directories. What's happening here? Why? Oh. So if the component is empty or if it's equal to a period, single period, we are going to skip the component. If the component is going to be a double period, we are going to go up one level by removing the last directory. And if the stack is not empty, we need to check that. Now, after checking all these conditions, we know that we have a valid directory. If it's a valid directory or a file name, we add it to the stack. Now the next step is to build the simplified path. So now we need to return now root if the result is empty. So let's do that. So now we can do an example walkthrough. Here we can look at this example 3 here, because that's a bigger one. Let's look at this. So here that's the input, and so the first step is that we are going to split the components. So the components array, these are the elements in the components array. After splitting okay, as we can see, there's a space here, documents, and after documents it's going to be 2 periods. Okay, and now we are initializing an array list, and then now let's go into the loop. So we are processing each component. The first component is empty, so skip it, and here it's empty, so skip it. And the second component, it's a home, so we add home to the stack. I can just write it here. The first component is this one, so it's empty, so we're going to skip. And the second component, it's going to be home. So I'm going to add it to the stack. The stack is going to be to have this one, the array list. Yeah, it's valid, right? Yeah, it's not double period, or it's not empty, and so it's a valid directory, so we are gonna add it here. stack. The array list is going to contain home right now. And the third component, it's going to be user. And this is a valid one too, so we're going to add it to the array list. And the fourth component, here's the fourth component we have. And this is valid. It's not empty, or like that. It's not a single period, it's not a double period, so we're going right there. And the fourth period is going to be double dots. So if it's a double dot, we need to remove the last directory. So as we can see here, and before removing, we are checking that the array list is not empty, and if it is not, we are removing the last one, that is stack size -1. So remove the last directory. So now the stack is going to be just home and user. And the next component is going to be pictures, and this is a valid one. And so we are just going to add it to the stack. Okay, sounds good. Now we are in building the path, building the simplified path. It always starts with we have a string builder and we are appending it with root. It always starts with root, and then so we are looping through this array list, and the first element in the array list is home, and that's followed by, so we are appending it the home, and then we are appending a slash, and so we need to make sure that it is not the last element. If it's not the last element, we need to append a slash there next to the component. And then what's the next component that we have is user, and another slash, add a slash to it, and then pictures. This time we are not adding the slash because that's the last component there, and then we are returning the result.length. If it's not equal to 0, we are returning the result as a string, and Yeah, we are converting this string builder into a string, and then here if it is 0, yeah, here result, if it's 0, we need to return a root directory. Let's run this code. Okay. At 33 we have okay, so this should be within quotes. Okay, case 1 accepted, case 2, case 3, and case 4, and case 5. Let me submit it. Looks like it beats 98.83. Okay, and 3 minutes. Okay, sounds good.